Hey everyone. So hopefully you can see some slides. So I went a little bit extreme with this talk, and so thank you very much for having me. I'll just pull up the chat in case anyone has anything that they would like to. So I can see the chat in case anybody needs to get in touch with me. So I'm going to talk about three different aspects, and in the middle is going to be what the promised talk was, which is Spotify and APIs more generally. But what I wanted to do is sort of position that within a broader workflow and sort of take a step back from perhaps what you're used to doing day to day in your classes, and think about what we're doing here. Then the Spotify API will be one example, an instance of this, and then how, if you're interested in that, you might go forth trying to turn that into a career. So I'm an assistant professor here in the Faculty of Information and also the Department of Statistical Sciences. If you enjoy this talk, then I will be teaching STA 304 in the winter. My understanding is that I'm a bit of a polarizing lecturer, so you may need to take some opinions as to whether you actually want to do that or not. So what are we doing? What are we sort of doing here? So now I want to start with the very hungry caterpillar. And while the very hungry caterpillar may seem very far from the world of data, I actually think that there's a lot of similarities because the very hungry caterpillar, and also when we are doing statistics, ultimately what we're trying to do there is we're trying to tell a story and learn something about the world. Now when we're using data, we're trying to tell a convincing story, and that story may be something about predicting elections, which is how I got into statistics. I know that a lot of you will go on to get jobs where you're just trying to increase internet advertising click rates. Some of you may try to solve diseases. Some of you may enjoy using statistics to forecast basketball games. But in any case, it doesn't really matter. The key aspects are the same. When it comes to English stories, so when we're telling English stories, the English author, and we've got a photo of him here, Ian Forster, he says that there are several aspects that are common to all novels, and these are story, people, plot, fantasy, prophecy, pattern, and rhythm. And I think that when we're telling stories with data, there are similar concerns that apply regardless of setting. So in whatever setting you are applying it. So what is the data set? Who generated the data set and why? What is the process that underpins the data set? And given that process, what is missing from the data set or being poorly measured? Could other data sets have been generated? And if so, how different could they have been? What is the data set trying to say, and how can we let it say this? What else could it say? How do we decide between these? What are we hoping others will see from this data set, and how can we convince them of this? How much work must we do to convince them? And to what extent can we share how we came to believe this ourselves? Who is affected by the processes and the outcomes related to this data? To what extent are they represented in the data set? And have they been part of conducting the analysis? Now, in the past, a lot of these elements were much easier, okay? So for instance, in the Faculty of Information, I teach a course called Experimental Design, and that has a very long and robust tradition in agricultural, medical settings. Some of you will be familiar with this man. Student's T distribution was identified by William Seeley Gossett, and he was working at Guinness, which as some of you will know is a beer manufacturer, and he needed to assess the quality of the beer. Now in that world, it's relatively straightforward to randomly sample some beer and change one aspect at a time. Many of the fundamentals of the statistical methods that we use today were developed in such settings. Those are the ones that in general, in the Department of Statistical Sciences, we teach you. And in those settings, it was possible to establish control groups and randomize, and there was fewer ethical concerns. And so any sort of like story that you tell with that data is fairly convincing. But unfortunately, little of that applies these days because we've got data science and we apply these tools to a huge diversity of settings. On the other hand, we have an awful lot of advantages over people like William Seeley Gossett. For instance, we have R, Python, SQL, and Terminal. We have well-developed statistical techniques, and we have enormous data sets. But ultimately, the fact that we cannot usually conduct a traditional experiment means we must turn to other aspects if we want to tell a convincing story. Now, I argue that there are going to be 5 components to the workflow that you need to tell a convincing story with data. And it's really only that 4th one that you cover most in your classes. And I sort of, I'm going to argue that, well, there's actually a whole bunch that has to happen before that. And there's some stuff that's got to happen after that. And that's what I'm trying to convince you of in this talk. Okay. So the first step is that we plan and sketch an endpoint. And we're going to see an example of all of this when we turn to the Spotify API. So we plan and sketch an endpoint because it ensures that we think carefully about what we want to do. It forces us to deeply consider our situation and it keeps us really focused. In Alice in Wonderland, Alice asked the Cheshire Cat which way she should go. Cheshire Cat replies by asking Alice where she would like to go. And when Alice says that she does not mind as long as she gets somewhere, the Cheshire Cat says, well, then it doesn't matter which way you go because you will always get somewhere if you walk long enough. The issue in our case is that we cannot afford to walk aimlessly for long. While it may be that that endpoint needs to change, it's important that this is a deliberate, reasoned change, and that is only possible given an initial target. We don't need to spend much time to get a lot of value from this. And in the example, I'll just spend a minute or two. And often I found that that's enough to get a lot of value. The next step is that we simulate some data. And the reason we do this is because it forces us into the details. The first step, we're very high level. And in this step, we're going into the weeds. Now, this helps when we start to clean and prepare the data set because it focuses our attention onto the classes of the data set of the data and the distributions of the values that we expect. Now, as I said, political science is what got me into all of this. So if we are thinking about the effect of age groups on political preferences, then we may consider that our age group column, so now we're thinking of it as a data set, we may think that our age group column would be a factor. And it might just have 4 possible variables. So 18 to 29, 30 to 44, 45 to 59, and 60 plus. The process of simulation provides us with really clear features that our real data set should satisfy. And drawing from computer science, we could actually use those features to define tests that would guide our data cleaning and preparation. So for instance, we could check that our real data set only contains one of those 4 age groups and throws an error if it contains anything other than those 4 age groups. When those tests pass, then we can be more confident that our age group column only contains values that we are expecting. Simulation is really cheap. Essentially free, given R and Python and modern computers, and it's really fast. And so the way to proceed is that you just start with a simulation that contains the essentials, get that working, and then complicate it. The next step is that you acquire and prepare the data. Now, this is, again, something that we often overlook in classes, okay? But as soon as you get thrown in the real world, this is something that you're going to have to do. And now at this stage of the workflow, it can be common to feel a little overwhelmed. Typically, the data in its original form can leave us a little scared. There may be too little of it, in which case we worry about how we're going to make our fancy statistical machinery work. Alternatively, we may have the other problem and be worried about how we can even begin to deal with such a large amount of data. And here I take comfort from a quote by Rilke, which is that perhaps all the dragons in our lives are princesses, who are only waiting to see us act just once with beauty and courage. Perhaps everything that frightens us is, in its deepest essence, something helpless that wants our love. Now, developing comfort in this stage of the workflow is really important, and it unlocks the rest of it. The data set that you need is in there, and what we need to do is just iteratively remove everything that is not the data set that we need and shape that which is. Now, I'm not going to spend too much time on this fourth aspect, which is exploring and understanding the data, because I know that you probably spend a lot of time on this in your classes. But I would just point out that the use of statistical models to understand the implications of our data is not free of bias, nor are they truth. They do what we tell them to do. Our models do what we tell them to do. Within a workflow to tell stories with data, statistical models are tools and approaches that we use to explore a data set in the same way that we use tables and graphs. And they will not provide us with a definitive result, but they help us to understand the data set more clearly. The model reflects decisions that were made in earlier stages of the workflow and indeed in earlier stages of our life. So sophisticated modelers know that statistical models are a little bit like the iceberg that sits above the surface, right? They build on the rest and are only possible due to the majority, which we never talk about. We never recognize. And so sophisticated modelers, and I hope that most of you are building towards becoming sophisticated modelers, they recognize that the results that we obtained are due to choices about whose data matters, how to measure and record the data, and other aspects about the world as it is, well before the data are available to us. And the final step of the workflow is that we would like to share what we did at as high fidelity as is possible. Now, move on. So how does our world become our data? Now, to a large extent, we are wasting our time here. We have a perfect model of the world. We have the world, right? The issue is that it's too complicated. We can't model with that. If we knew perfectly how everything was affected, then we could perfectly forecast a coin, dice roll, all of the other random processes that we use, okay? But we can't perfectly forecast that because we don't perfectly understand it. So what we need to do is we need to simplify things into that which is plausibly measurable. And that's what we define as our data. Our data are a simplification of a messy, complex world from which they were generated. There's different approximations of plausibly measurable. And so our data sets are always the result of choices. What we need to do is we need to decide whether they are nonetheless appropriate for the task that is at hand. The process of our world becoming data necessarily involves measurement. And one of the paradoxes that I've found in my experience with data science statistics is that paradoxically, those that do the measurement and are deeply immersed in it tend to trust the data less than those that are removed from it. Even seemingly clear tasks, and I'll turn to an example in a moment, such as measuring distance, defining boundaries, or counting populations, are surprisingly difficult in practice. Now, an example of this, of something that seems simple but quickly becomes difficult, is maternal mortality. What maternal mortality is, it's the number of women who die while pregnant or soon after termination from a cause related to the pregnancy or its management. Now, it's really difficult, but it's critical to measure this because that enables us to mitigate future deaths. Some countries, such as Canada, have very well developed civil registration and vital statistics. Canada, especially Ontario, collects data about pretty much every single death, and we know cause of death and all of that. But many countries do not have a CRVS, civil registration and vital statistics. And so not every death is recorded. And even when a death is recorded, defining a cause may be difficult, especially when there's a lack of qualified medical personnel or equipment. The issue is that we use instruments to turn our world into data. And so in astronomy, we have telescopes and satellites and probes. And as we develop new instruments, we get new data. And that's the same in the world today of data science. So we used to only have a census, which would happen once a decade. But now we have regular surveys, transactions data. And so it's a very exciting time. Right? Our world imperfectly becomes data. But if we are to nonetheless use data to learn about the world, then we need to actively seek to understand the ways in which they are imperfect. So at this point, I'll turn to an example of all of this. And what we're going to do is we're going to turn to using APIs. So in everyday language, and for our purposes, sorry, I'll just pull up an API. Right, here we go. Oh. An application programming interface, an API, is simply a situation in which somebody has set up specific files on their computer such that you can follow their instructions to get them. More strictly, an API is an application that runs on a server that we access using the HTTP protocol. Now, in our case, the focus is going to be on using APIs to gather data. So I'm going to tailor the language that I use towards that. But what that means is that an API, for our purposes, is a tool that makes a website's data digestible for a computer. Through it, a computer can view and edit data, just like a person can, by loading pages and submitting forms. Now, in the example here, we've gone to Google Maps and we've scrolled and we've dragged and we end up somewhere, okay? So that's me using it. An alternative is that we just copy this, okay, and we paste it in, okay? And in that case, we just use the Google Maps API. Now, the advantage of using an API is that the data provider, in this case, Google Maps, has specified exactly the data that they are willing to provide and the terms under which they will provide it. These terms may include things like rate limits, which is how often we can ask for data. So if I pasted that many times, eventually we would be hit with various captions, and what you can do with it. Additionally, because the API is being provided specifically for you to use, it's less likely that there will be unexpected changes. Because of this, I feel that it is ethically and legally clear that when an API is available, you should try to use it. Now, in this first example of using an API, we're going to deal with, we're going to gather some data from archive. So just to show you, so what archive is it's a repository of various papers. So we can find some papers about astrophysics here if we wanted. So we'll go in here and we can see, okay, so here's a paper about astrophysics, and we could go and we could have a look at the PDF, and hey, here's a paper about astrophysics. Okay, so that's what archive is. It's a collection of papers, and so scientists, even data scientists, statisticians, use archive all the time to share their work. In this case, we're going to use the archive API to download some data. So we're going to use the package. Sorry, I beg your pardon. I'll just make this a little bit bigger. Right, there we go. I do apologize for that. I'm not teaching in full, so it's been a while. So we're going to use the library HTTR. If you've never used this before, you may need to install the package, which is going to look something like that. Okay, so you would run that line. So here I've highlighted it, and on my Mac, I'm just about to hit Command and Enter if I wanted to execute that. Now I've already installed that, so I don't need to run that, but I'll just leave it there in case you're following along. So, oh, I do apologize. I've be HTTR, right? So in my case, we need to load the library. And so again, I've just highlighted that, and I'll just do that again. Highlighted that and hit Control Enter, and that just runs that line that's highlighted. Pull this up so that we can see. Okay. And now within this package, the specific function that we're going to get that we're going to use is the get function. So just say we didn't know what we were looking for, we could pull up a list of all the different functions in this library. In this case, we want the get function, and we can see that it takes a URL, config, and handle. And it turns out that the only argument that we have to give it is a URL. Now I'm just going to copy the URL. So this is the one that we're interested in getting. Shift this over so that we can see everything. And we're going to assign this to a name. We're just going to call it archive. So again, highlighting this, hitting Command Enter, and what that has popped up is it's used the archive API, and we've got some data. And we're just going to unpack it just so you can see what it looks like. So again, content, and this is a function from HTTR. It takes as its first argument some data set. So this is the one that we just labeled before. And then we need to tell it what type of return we want. And I'll just need to run the tidyverse. And what tidyverse allows me to do is it allows me to use the pipe here. Now this line here, we don't need to worry too much about the details, but what it's doing is it's just splitting it up, our data. So what it's going to do is it's just going to print nicely. That's essentially what's going to happen. So I'm going to highlight this, I'm going to execute it, and we can see that we have actually downloaded a data set, and it's called the increased effect of elections and change prime ministers on topics discussed in the Australian Parliament House. And I'll just show you that actual one. And so that's the paper that we just downloaded. So that's our first API. So that may seem pretty boring. That may seem pretty boring to you, but with an undergraduate statistics student, actually over the summer, we used just exactly this process to download tens of thousands of papers from these preprint repositories. So this is Annie Collins, some of you will know her. And what we did was we then passed that information. So we analyzed this information here to look for examples of whether the code and whether the paper was reproducible. And we found that in most cases, it was the papers are not reproducible. So that's the advantage of using APIs, is that it allows us to go from just using one example to being able to do tens of thousands of samples really quickly. Okay, let's move on to another example. So this is going to be Twitter. Now, again, there's an R package that we can use, and it's rtweet. So you're not going to have this. So if you don't have this package, then you'll need to install it. Install packages, rtweet. And so you need to run that if you don't have the package. Otherwise, tweet. Okay, and what this does is it allows us to talk to the Twitter API. I'll just show you what the Twitter API documentation looks like. The reason that I always start with this API early on is because you can use some of it without needing to register as a developer. Our third example the Spotify API, you have to register as a developer. It's not a big problem. But the advantage of starting early with the Twitter one is that you don't necessarily have to register. So if you go to this developer.twitter, the nice thing is that it has a lot of docs, and we'll return to these in a moment. But let's just jump in. Let's just jump in and start using this thing. So I won't forget to load the tidyverse again, although in this case it's a little superfluous because we've actually been using it. And so let's just get my favorites. So I'll just use myself as an example. So tweet, get favorites. And in this case, you can see that we've got a variety of arguments that the function needs to take, but the only compulsory one is a user. So right now what it's doing is it's going up to Twitter and it's getting a whole bunch of different information. And it turns out that I just liked Charlotte Gelfand's tweets, which is, if any of you know Charlotte. And so we might just assign that to a name. So we'll just call it Rohan's faves. And that way we've just created an object so then we can have a look at it. And we could just tidy it up and just use a small subset of these. The shortcut that I'm using to get that pipe is Command-Shift-M. So you on a Mac, Command-Shift-M, and that just automatically pulls up that pipe for you. Arrange. So I'm here with select. I'm just grabbing just a few of the columns. So we're just going to get 2 of the columns so that we can actually read this thing. And so as you can see, this most recent tweet that I liked was by Charles, and they're saying it's Recreation Thursday. This one's for all of you data people. And it turns out that they're talking about reproducing a sort of very nice graphic, essentially. Another thing that we can do with this API is that we can look at who's been tweeting about certain things. So let's look at who's been tweeting about R. So in this case, we need a query. And so we're going to do hashtag R stats, which is a common hashtag. And do we want to include retweets? We won't. And so again, when we highlight this and execute it, it's going to go to the API. It's going to have a look at some of the recent RStats tweets. And another way to look at the data, so we've been executing this data and looking in the console, but we can actually just click on it here and we can have a look at it in a more traditional sort of way. And so this person, this most recent one, was in Rennie 35 and it's 30-day map challenge, day 18 water. So I guess they're using some sort of package to make a map of water, which is nice, obviously. If we wanted to have a look at all of the different values of the columns, we could use names. So highlighting that, executing that, we can see that we've got 90 different columns, a whole variety. And so we could have a look at through some of this, and we could pull out a few of the columns that we're interested in. But in our case, I'll just pull out a few that I know are useful, and that's screen name and text. Okay, and so there we get our information about NRennie and their 30-day map challenge. Now there is a bunch of cool things that you can do just if you only have a regular Twitter account. But if you're interested in doing this more seriously, then you can register for a developer account. So what you do is you register as a developer, and then you can actually take advantage of some of the other features of this. And if you're going to do that, then I would actually recommend reading some of the Twitter docs, and that's just telling you about how to use the API. And so it's actually surprisingly readable. When at the top of this section of talking about APIs, I said that when the data provider specifically specifies exactly the data that they are willing to provide, and we've certainly been able to take advantage of what they provided. And I continued and I said, and the terms under which they will provide it. And here we haven't really done our bit, right? Because we've taken some of their tweets and we saved them. And if I push them to GitHub, which is perfectly reasonable in terms of a communication side, then it's possible that I may have accidentally stored sensitive information if there happens to be some in these tweets. And this is one of the dangers, but it doesn't look like there's anything too dangerous here, but it's possible, right? Or if I had taken enough tweets to start to do some reasonable statistical analysis, then even if there wasn't sensitive information, I may have violated the tweets. In this case, I did link a Twitter username. It was Charlotte with a real person, Charlotte Gelfand. Now, in this case, I happened to ask them if this was okay ahead of this, but if I hadn't have done that, I would have been violating the Twitter's API's terms of use. So it's quite important, if we're going to be using APIs more seriously, to read as much as it's possible. And so, for instance, in the case, I said that the Twitter docs are very useful. So they actually provide quite a lot of information about restricted uses of the Twitter API. And so, for instance, never derive information about a Twitter user's health, for instance, which is never derive information about a Twitter user's political affiliation. Okay. And believe me when I tell you that it's done all the time. So people are just violating the Twitter API. Okay, so now let's get a little bit more serious about this. Let's turn to Spotify. And I really like the Spotify API because it just allows us to do potentially some quite interesting things. Again, we can access this from R using the package Spotify R. And so you can install that from CRAN if you would like. And so in this case, it's Spotify R. And so you highlight and then execute that. In my case, I have the thing, so we'll just load it. Okay. Now, in order to use the account, you need a Spotify developer account. And you can set that up if you want. So I'll just, what you do is you just go to the developer. You go to the Spotify developer website. So here you can see Spotify developer.spotify.com. And at this point, you can create a developer account. At that point, you'll need to log in with your Spotify ID and all the rest of it. So I'll just log in here. I will pull this off to one side just because we're recording it, but it's okay. Okay, and when you do that, you'll come up with a dashboard. You can see I've already got some silly ones here. I did actually practice this before we took it. But what we want to do is we want to create an account, an app, beg your pardon. So we want this button here. It's going to ask you for an app name. So we'll just say SSU example and an app description. Just get used to get some example data. we're going to have to agree with the developer terms of service and branding guidelines. Okay, so we're going to create this. Now, what we're after here, what we need is we need two things. We need this client ID, and I'm going to show you how to do all of this in a moment. We need this client ID. And then if you click on this, it'll expand out and you'll get another option here, which is going to say client secret. Okay, and that's a password essentially. So those are the two things that we're going to need. And we're going to need to tell R to keep it we need to save this in R. Okay. Now there's a variety of ways to keep this to yourself, these secrets to yourself. But one way is to keep it in your system environment. And the advantage of this is that when you push to GitHub, they won't be included. Okay, so we need these keys, but we want to keep these keys to ourselves so that other people can't use our API access. So the only trick is that we need to specify, we need to save our keys somehow, okay? And we're going to use a package called use this for this. Use this, and we're going to edit our R environment. Okay, and what we're going to do is when we run this, and I'll just run this off the screen and then I'll pull back in so that you can see the results. But it's going to so what it does is it opens a file called a .renviron file. Okay, and then what you want to do is you want to put your client secret and your Spotify client ID there. Okay, so we're going to put Spotify client ID. And so in my case, I've just lost it. Oh, here it is. So in our case, it's this value. Okay. And then we're going to need to put our Spotify client secret. Okay, and so for this value, what you're going to do is you're going to come here, you're going to show client secret, you're going to copy it, and then you're going to paste it in here exactly like that before. At that point, you then save the R environment. Okay, so we'll pretend that I'd pasted it in here. We save this R environment, and we go to session, and you restart R. Okay. So what I'm going to do is I'm just going to put the real secret in, and then I will drag this back. So you put the real secret in, you save it, and then you restart R. And so then you can close the R environment. Okay. So we have our client secret saved within our R environment. And at this point, we can get some information, we can get some data. So what we're going to do is we're going to try and think about what our data set might look like. Okay. So one data set that we might be interested in is something that's like we might be interested in some in an artist. Okay. And we might be interested in knowing how long each of their songs goes for over time. Okay, so what that might look like, I'm just getting a book so I can show you here. What that might look like, and this is part of our process, right? So that might look like an artist. So we might be hoping to get artist in one column, and then we might like to get track length, And then our rows are going to be each song. So we might expect, so our first example, we'll just do Radiohead. And so it might be Radiohead. And at this point, we need to think a lot about what is a track length. So it might be, okay, sorry. So I'm showing you just in my camera. Thanks, Arjun, for specifying that. Jay, what were the two values you need to put in the R environment? I'll come back to that and redo that just once I finish here. And so what we might want to do here is track length, maybe it's going to be in seconds, and so it might be something like 100 or 350 or something like that. Okay. And so what we've done is we've just taken one moment and we've just sort of sketched out exactly what we might expect our data set to look like. What that then allows us to do is we could write some tests to ensure. Okay, and so just to redo the two values that you need in the R environment. So you need this client ID, and then you need to click show client secret, and then you need the Spotify client secret. And as Sammy says, they need to be specifically named Spotify client ID and Spotify client secrets. And so I'll just redo this so that you can see it. And so it'll look something like this. Okay, so you're going to post, you can see how this client ID here is the same as this. And then you just click on show client secret and you copy that in here to very secret. Okay, so I'll just do that now. Sorry, let's just pretend that this is my secret. Then we'll save that, and then you go up here and you go sessions and you restart R, and that just makes it reuse it. Okay. So I'm just doing that again off screen. Restart R. Okay. So we have all of our information now. So let's get our Radiohead information. And so we're going to do that using get artist. Maybe I forgot to load this. So when we restarted R, we're going to need to restart Spotify, and we need to re-get tidyverse as well. Okay, so now we can Spotify, and we're going to get artist features. And in this case, you can see that we need an artist. We need, that's actually the only compulsory one. So in this case, we'll just do Radiohead, and we'll save it to a thing called Radiohead. So it's now going to the Spotify API, and we're getting some information, and we've got some information about Radiohead, which is great. You can see it's a little bit different to how we were expecting, what we were hoping for in our sketch, right? We've got a whole lot of different variables, of different variables. And so we might like to just select down to a few that we think might be especially useful. And then have a look at those. And just have a look at the first 5 or 6 of them. And so we can see that our first album here that we're getting is Kid A, and there was a re-release of it recently, which is why it's coming up first. And so now we can make a quick graph of track length over time if we wanted to. I think I've messed up. I've got one too many brackets. And if we've done this right, we get so we can see that they started, their songs are arguably gradually getting longer. As I said, this is that re-release. Another thing that is useful is that, so I've always said that Radiohead is like quite depressing, but it's my wife's favorite band. They're my wife's favorite band. And so Spotify API actually provides information about how happy a song is. It's called valence. And so it's a measure of 0 to 1, describing how positive a music track is. So higher tracks, closer to 1 means happier. Okay. So let's compare Radiohead with Taylor Swift. So again, we'll just quickly go and get Taylor Swift's information in the same way that we got Radiohead's. And at this point, we can use valence. It is still thinking. It just takes a while to get Taylor Swift, but we can use valence. So we're going to create a data set. That is all of the names. The year, so we're going to compare this over time. Push a bit wider so that you can see. And we want valence. Okay, so let's just have a quick look at this. Okay, so this looks like we've got what we wanted. So we'll pipe this to a plot. I'm always a fan of labeling my charts to the extent that's possible. So the way that I normally do that is labs. There's a whole bunch of different ways. That's one of the troubles with R, is that there's always a bunch of different ways to do things. But and then we'll just change the colors so that they look nice. Okay, and if we've done this right, then we're going to get a nice chart that will show whether Radiohead or Taylor Swift is happier. Remembering that closer to 1 is happier, and so I think that it's fairly inarguable probably that that Taylor Swift is happier than Radiohead. So there's a question are we able to take samples of lots of artists on Spotify to summarize or analyze without naming them specifically? I'm not quite sure if you can just sort of like grab a whole bunch of recent ones. The way that I would do it is I would get a list. I would look at a list of like top 100 artists or something like that, and then I would feed that in so that you could then save the information and get it in a more reproducible way. And so that way you're not reliant on the Spotify API, sort of like just giving you some random collection. But yeah, I'm not entirely sure if it's possible to just get some random selection. So that's using the Spotify API. It's fairly amazing that we live in a world where all of this sort of information is very available with very little effort or cost. I have 4 more minutes, so I'll just close with a few. Oh, sorry. The question: the API doesn't have seen data on the language of a song. Is there a way to do this ourselves, as in classify it as English or not? Is that the question, Sammy? Yeah, my feeling would be that there would be various natural language processing packages that would be able to tell you if it was English or not. But yeah, I'm not sure off the top of my head. Spotify, right? So it's going to be fairly biased towards English. Yeah, that's so your suggestion is taking the string of name and using some sort of API like Google Translate API or something like that. That's sort of what that would be what I would go to as well. Right, so I'll just stop sharing and just 3 minutes remaining. So let's just say that, you're super excited by all of this, and you really want to, get to work in this area. Okay. Now, there's a question about the code. So I'll share my screen so that you can see that while I'm talking. And you wanted the top. Is that what you wanted? Let's pull out the chat. Does that work for you, Yusuf? So let's just say that you've been super excited about all of this and you really want to go on and do data science. So right now as students, you're paying to get to do all of this, right? You're paying to take classes. And ideally what you actually want is you actually want to be paid, okay? Now, this is all caveated by the fact to say that like this was all a lot easier for me, okay? There was just a lot less competition for me than there is for you. But typically most of you will want to go to grad school, and there's 3 bits for your grad school application. You need your transcript, you need a cover letter, and you need references, typically, right? And you're spending 4 or 5 years getting these transcripts, right? And so it always baffles me that students don't spend an equivalent amount of time, or a substantial amount of time, also trying to get good reference letters. Okay, the best reference letters are written by people that have worked with you, ideally professors, if you can manage it. Okay, and so ideally, what you want to do is you want to try and work with professors for a year or 2 during your undergraduate. Okay. And so how do you get to work with professors? Well, basically, I think that what you want to do is you want to show a professor that you've got an interest and some skills. Okay. And so one way to do this is to demonstrate interest in coding and data science. And so these days, a lot of papers need an R package to go alongside them. Yusuf, have you got all the code? I'll stop screen sharing. And so these days, a lot of papers need an R package to go alongside them. Okay, but and so if a student emailed me having made an R package and demonstrated this on GitHub, then it would be really easy for me to see how I could use them in my research. Okay, and that is very different to a situation where a student emails me saying, hey, I love R, I love whatever, can I work with you? Okay, I have no way of understanding what level you're at or how you could contribute in that second case. But if you email me with a link to a GitHub repo and you're like, hey, here's an R package I made, it does X, then it's very clear. Okay. Another way, another thing that you could do is to demonstrate some interest and skills is through a data sheet. And what a data sheet does is it documents a data set. Again, what it does is it shows that you've got an awful lot of genuine interest and some skills. And again, it's really clear how a professor could use you, if that's what you're wanting to do. So it is 2 o'clock, so I should stop here. But I'll just put my details into the chat, and then if anyone wants to get in touch, you are welcome to. But otherwise, thank you very much to the organizers for having me. And I'll stop recording and I'll just put my email into the chat so that folks can get in touch if they want. If you have any questions, I'm around.